Phone? How's that? Okay, here we go. All right, give me a thumbs up if you can hear me. Hey Franklin, it's good to see you. And let's see if the emojis are working. So I'm gonna give myself all the emojis. And then, let's see if this works. Yeah, so I can hear myself. So it seems we're good. All right. Right, so for today, I want to pick up where we left last time. So last time in the outro, it got a little bit lengthy as I was trying to explain something that is probably easier to show than explain, and I'm not gonna make the mistake of trying to explain before I show it. So without further ado, let's go into the coding view here. And what I referred to last time was a blog post by Majid that he posted a couple of days ago. So let's go to the blog posts. So it is this one here, building AI features using foundation models. And there is a bunch of stuff that he covers in this blog post. So one thing that really got my attention is how he structures this functionality into a struct, right? So he has this intelligence struct here, and then there is a generate function that does some sanity checking to make sure that you can actually call the language model session. And then he sets up the session and performs the call. So one thing that I found quite interesting is this bit here, where if the system language model is not available, he'll immediately return the input. And that might seem like something that's not like a super smart idea, because if you ask the model to generate some text or summarize some text, then returning the input doesn't sound like such an amazing idea. So for example, in our case, where I have this knowledge base app and I have an article that is like, let's say, a couple of pages long, and I'll pass it to this generate function here, and then because, I don't know, maybe I'm running on an older device, or for some other reason the model is not available, it will return the original text. So is that a good idea or not? In our case, probably not. So, and yeah, so why not return nil, right? So that's exactly what you would maybe do in that case, or maybe throw. But in this case here, if you look at this this code screenshot that Majid created and that he shared on social media, you can see why in very, very narrow circumstances it might actually be an okay idea to do this, right? So here the use case is that in his app he wants to recommend what the user should do or how they should adjust their nutrition. And you can see that we've got the system instructions up here saying you are a healthy lifestyle coach, write a recommendation, keep it short, positive, and inspiring. And then, oh, you can't actually see it in this one. I need to find the other one. So let me quickly find the post. And let's do it over here. So I think it was somewhere on Twitter. Swift with Majid. this one. Yeah, so I've got it. Let me save it to the desktop. And then let's see. Here we go. Okay, here it is. So if you look at that last line here, try await intelligence.generate boost protein intake. So that is written in a way that if the model is not available, you could actually show it to the user, because that might be something that the user can understand and which is like a good recommendation. Obviously, if you send that to the model, it can give you a much better or a more nicely phrased recommendation. And if you provide more context, for example, the user's preferred meal types or their additional health data, then you could generate like a really useful message. But this short message here would still work, but it's a very, very narrow use case. But I really like the structure. So, encapsulate this thing in kind of like a reusable, compact use case. And I thought, why not use this as an inspiration and use it in our application as well? And that's what I wanted to do today. So let's go into the code, and this is where we're currently at, and I'm gonna run this on the simulator real quick so that we can see what is going on. So we've got our application over here, and then I can go in and we've got 2 blog posts here. And let's look at this one that Natalia shared a couple of weeks ago. And if I tap on this button here, we will get a summary. And that summary is generated by this summarizer service here. And the summarizer service uses Firebase AI logic. It uses the Gemini 2.5 flashlight model. And we can also take a quick look into the Firebase console and take a look at one of the new features that just got launched a couple of weeks ago, which is AI monitoring. So here in the AI monitoring dashboard, I can see all the calls that I'm sending to Firebase AI logic. So you can see the tokens that you send in, and they're categorized by texts, image. So I'm not sending any images or videos, audios, or documents, which are PDF files. So everything is text. I can see the input tokens, the output tokens, and the thinking tokens. And it's also highlighted which APIs I use. So you can see which calls came from the Gemini Developer API and which ones came through the Vertex AI Gemini API. And down here, you can see those calls. So you can see that this one, for example, is the call that I just sent. And you can see that the response came back in half a second, which is really nice and snappy. Here's my input. So here are my system instructions. Create a short, snappy, informative summary. And then here is the text to summarize. So all of the rest is Natalia's blog post. And then down here, we can see the response. So quite nice. But what, and I really like how snappy this is. So it was, I didn't have to wait long. And I think, waiting for half a second, that is definitely, fast enough for those use cases. People would probably be happy to wait slightly longer if you show a nice animation. I experimented with other Gemini models. So if you use Gemini, yeah, let's do it. So you know, let's use Gemini 2.5 Flash and see how fast that is. And we can see it in a dashboard and actually compare the times. So I'll go in. No, let's take the same post, and then it takes slightly longer. Wait, and here we go. And now let's take a look at the dashboard. So it took 4.31 seconds, which is still acceptable, I think, but it's a lot slower. And if we look at the summary, I think it's about the same quality as we got from Flashlight, right? So I think for summarizing text, it's okay to use a model like Flashlight that's small and fast. So let's also try a thinking model, and we can use the Pro model, not programming. And that will take a lot longer. So I think that will take about 12 seconds. So let's do the same. And now we'll have to wait for more time. So that would definitely call for some animation there to entertain the user and tell them, hey, you know, be patient, the good stuff is still coming. And I don't think that the quality is so much better, right? And that's obviously also got to do with the kind of prompt that we're using here. So let's refresh this once more and then look at how much time this took. So 13 seconds, right? Yeah, and so yeah, Google AI also has monitoring. So let's show this. So I can just go in and I can switch the backend I want to use right here. So I can say I want to use Google AI, run this again, and we still have access to all the models. And run another summary. And while that's running, I'll just take a sip of my tea. Okay, so same kind of summary, and then if we go back into the console and refresh that, we can see, hello, we can see that, let's see, where does it tell me which API it used? Let's see, does it tell me? Or maybe, let's double check. API provider, so let's filter. So it seems like it might not be showing this in a table. Maybe, I don't know, maybe is the table not wide enough? Is that the reason? No. Yeah, so it's just not showing this as a column, but if you filter, you can see that, all right, so this one was the one that we, where we use the developer API. All right. Yeah, so Franklin, you're exactly right. A couple of weeks ago, that was not yet supported. So AI monitoring for the developer API, that's something that we launched quite recently. It might have been announced on the blog. Let's do a quick double check here. Grounding, Data Connect. There is so much stuff that we've been launching. It might have been in the release notes. So if you search for Firebase release notes, you can see. All right, so here we go. So here it says, Firebase AI Logic now provides AI monitoring in the Firebase console when using the Gemini Developer API as your API provider. You could previously only use it with the Vertex AI Gemini API. So that's new as of a couple of days ago. Right, nice. So, but what I wanted to explore was, can we use both local inference and remote inference? So can we use a local model, a local on-device model, and if that's not available, can we then fall back to a remote model? So, and in order to do that, what I'm going to do is, let me take a quick look at my notes so I'm not doing it the wrong way. So here we go. So I will create a new struct that will allow me to encapsulate the functionality. So I'm taking a page out of Majid's book here. So we've got a structy local summarizer, and in that local summarizer, let's have private let instructions, and that can be our system instructions. And the reason why I want to why I'm doing it this way is that maybe depending on the kind of model you're using, you might want to use different system instructions, right? So you might want to tune your system instructions to the kind of model that you're using. So yeah, and Franklin, you're absolutely right to raise this question. What criteria are you using for deciding between executing inference locally on device versus offloading it to the cloud? So the very first thing that I want to make sure here is that I can. So for example, if this phone here, that's an iPhone 13 Pro. It's a really nice device, and I still really like it, but it doesn't have support for Apple Intelligence. So there is no way how this, it's not an old device by any measures, right? It is a couple of years old. It's perfectly okay. It's fast enough to do everything you want, and it's a wonderful phone. Great camera still. So why shouldn't the features that I want to implement not be available on that kind of phone, right? I want to make AI features available to people who are using phones like that. So that is one reason why we want to do this, right? So if no local model is available, I want to offload to the cloud. So that's one reason. Or maybe another reason is the context window size. So the Apple Foundation, it's such a complicated API name. the foundation model framework, or the models that the foundation model framework supports at the moment, have a context window size of 4096 tokens, and that is not a lot. And we will see in a moment, once I've implemented this, that it actually, runs into this limitation even for moderately complex blog posts. So that might be another reason, once you realize, oh, well, the input is too large, let's rather go and do that on the cloud. So these are a couple of reasons, and I'm sure there are more reasons, and we can discuss this more, but let's go and continue the implementation. So I've got my system instructions here, and then I want to have a function that's called summarize. We can just copy this signature from here. And then let's do let system language model.default is available, else. Oh, is this an error that we have? Nope. Let's generate one. It's probably doing a lot more than I wanted. Well, but that's not too bad. Yeah. Why did you remove this? Why? Oh my God. Maybe let's not show change. Can I reject this change? I don't want this change. No, hide change. Anyway, I'll just copy this and then, oh, come on, hide the change. Here we go. So if it's not available, we will throw this, and we also need to import foundation models, right? Is that? Oh, and also this is only available on iOS 26. So for now, we are going to add this thing to the struct. And not let, but this way. All right, so now we're gonna instantiate a language model session, and we are going to use those instructions, and then we'll call the session and ask it to, should be respond. Oh, it's not respond with, that is really weird, because they should know their own APIs. Response.content. Yeah, this is, okay, like this. Okay, right. All right, let me check who's here today. So we've got Dan, we've got Lars, we've got Evelyn, Franklin. So we've got the regulars. Nice. I love it. If there are any other folks on the stream, feel free to wave and, send an emoji. And also, are we still on? Yes, we are. Sometimes this iPad drops out. So we've got our local summarizer. Here's our input. So that should work, right? So the next thing I want to do is I'm going to rip out this stuff here and put it into a remote summarizer. So I am going to copy this entire thing here and then call it remote summarizer. And for now, the system instructions are going to be just the same. But let's replace this here. And now I'm going to copy all of this into the summarize function. And now let's use Vertex AI. And let's initialize the model. We're going to use the system instructions. And to do that, we will have to use this here. So model content, and the role is system, and parts is an array. Oops, so you can let's see, can we just pass the string like this? Seems like, yeah. So, and then generate content based on the input. Like this. Okay, let's double check. So we've got our instructions, we've got our input. We'll set up Firebase AI logic using the Vertex AI backend, and we set up the system instructions. Let's format this nicely. We're passing in the instructions, we generate the content, and then we return the text. Nice. And by the way, Evelyn, I'm not using an iPad for coding. I'm using an iPad to watch the stream, so to monitor if everything's still live, right? So for example, if for some reason the internet connection broke down, I would see it on the iPad. That's just double checking. All right, so, and now we can remove all of this here, and let's return try await local summarizer dot summarize using the input. All right, so now this is telling me this is only available on iOS 26 or newer, right? So what we can do now, and this is just like the first step on this, we'll just say if available iOS 26, then we'll do that. And otherwise, we will use our remote summarizer. Remote summarizer dot summarize input. Yep, and this also needs to be try await. Nice. So, and just so it is easier for us to see what's actually happening, is we will log a couple of statements. Attempting local inference using remote inference. Not that's not an emulation, that's a real thing. Honey. For real. So, all right, let's actually try this. So let's run this on the iOS simulator. So here is our blog post. Let's go in, tap the button, attempting local inference. And what's happening? Okay, nothing is happening because we didn't catch the error, right? Did we? No, we didn't. So first of all, this might throw, and then this might also throw, and we're not catching this. So that's probably something that we should do. So let's go in and do a little bit of error handling. Yeah, so that's actually a smart idea. So first we will attempt local inference, and if it throws for any reason, and we'll see a couple of reasons in a moment, then it will say, well, you know, there was an error. Maybe we should say there was an error. Local inference failed using a remote inference, and then logger.error. We're gonna log the error. All right, so let's try this again and then see what was the problem here. I have a couple of ideas what might have been the problem. So, attempting local inference. Ooh. This is interesting. So let's see what is happening here. So, ooh. We need to use a local summarizer. Okay. Also now I'm a little bit worried why the remote summarizer did not return anything, but let's see. So attempting local inference, and here is our summary. So that worked. Now let's run this on iOS 18.6 and see what happens there. So when should you use system instructions, and when is it better to use a prompt with instructions? So I think it depends on the model, right? So some models just don't support system instructions. Most models these days do. So if you're working with models that don't support system instructions, then just put it into your prompt. But I think it's a nice idea to to use system instructions if possible. All right, so this user is not signed in, or there is no user who is signed in. Let's quickly do that. And let me get the password for Fred Firebase. Here we go. A fantastic password. Here are our 2 blog posts, and let's try to summarize. So, using remote inference, and now let's understand why this does not work. Oh, it did work. It just took such a long time. All right. So I think we should also switch back to Flashlight. Really, that's just another sign that we really need to work on our user experience there. Oh man. How many times has it happened to you that you thought, oh, it's completely broken, only to later find out that it wasn't broken, it was just slow? Here we go. Let's try it again. Summarize. Yeah, we probably don't need the breakpoint. Here we go. And yeah, it used remote inference. Let me see, was there? Oh yeah, so there was one other thing that I wanted to add, and that was logger.debug summarizing input privacy dot public. So we can actually see what we're summarizing. Okay. Let's give this another go. Summarize. Okay, and here we can see the entire blog post that we're summarizing. Nice. So, one interesting thing about whether or not you can use the foundation models is the language that you're using on your device. So let's go into the simulator and see if I can demonstrate this. One thing that I like to do is set my devices to Australian English, and the reason why is that I really like how the voices sound, and the slight Australian accent is I just love it. So if you do that, so let's just start with this. So if we go into the Apple Intelligence section and then configure, where's Australia? And then configure Australia and then choose one of those voices. So I don't know if you were able to hear that, but I think it sounds just fantastic. So let's try running this again, and I can just go back here Oh, wait. Sorry, I need to do this in the 26 emulator. And actually, let's run on the emulator so we can see the error message if there is one. Sorry about that. So, I'm going to delete all of this and then, oh, it did work. That's interesting. So, well, I haven't changed the language yet, so sorry. Let me change the language. Let's go to Australian.
The colours of the sky fade with the setting sun as the stars begin to shine through the clear night.
Let's use a male voice. And then make sure we're connected to the debugger. And go here and then do this again. Okay, so this is still working. Let's see, because there was some really funny configuration where it didn't work. Let me switch to English Australia for the device language. And the thing is, you can only use Apple Intelligence in the simulator if your host, as in your Mac, also supports Apple Intelligence. So if for some reason your Mac does not support Apple Intelligence, for example, because it's an Intel machine, or maybe because you have a mismatching language configuration like the one that I'm trying to produce here, or maybe because Apple Intelligence is turned off on your Mac, then it also won't work on the device. So let me give this another try. Okay, so this still works. That's really interesting because I absolutely did have a situation where it didn't work for me, and then I realized that I should make sure that both my simulator and my host system are on the same language setting. So this is on English UK. Apple Intelligence is on. It's set to English UK. And I would have thought that if I set the simulator to a different configuration, that it would break essentially, right? But apparently that is not the case. So if I turn this off here and then try this again, maybe that will cause it to break. Let's see. Yep. So it said attempting local inference, and then we get this really strange error message here saying something about the model catalog, and then it also says something about safety guardrails were triggered. If this is unexpected, I guess it is, please use language model session.log feedback attachment to export the feedback attachment and file a feedback report. But thanks to our fallback mechanism, we're using remote inference. So let me turn this back on. And then see if this works again. All right, so well, for some reason, I was actually hesitant if I should do this. Okay, so now it has finished. I don't know, for whatever reason, it had to download the thing again. Maybe they're just deleting it. Might make sense. Or maybe not. Okay. Nope. Oh, maybe now we're in the situation that I was trying to show you before, right? So my host system is configured to English UK, but my simulator is configured to Australia. So and actually a simpler way to demonstrate this, and also to demonstrate that it's not a programming mistake on my end, is to use this amazing sample app that Rudrank put together. So let's run this here, and then, oh, look at that. Now it's working again. This is so funny. Okay, maybe it just took a moment. Or maybe there is another thing that we need to look after. Select all, delete this. Yep, so now it's working again. So it was probably just a matter of a couple of seconds of waiting until the model became available. Right, so this is the basic infrastructure for hybrid AI. So now what I want to do is, if you look at the local summarizer and the remote summarizer, they are really, really similar. And I want to make my code, a little bit nicer to read. So let's go and define a protocol. What do I want it to call? Let's double check. So I wanted to call it Inferencer. Inferencer. And I want to be able to check if an inferencer is available. So I'll add is available. And then we'll also add this function here. But because we might do other things instead of summarizing, let's call it infer. And then we're going to create a default inferencer. Yep, nice. And then we are going to update our local summarizer and turn it into an inferencer. So struct local summarizer is an inferencer. and it doesn't conform to the protocol, and that is because we haven't yet implemented the isAvailable function. So we're going to do that real quick, and also we'll need to update the infer function. So let me move the instructions to the top, and then we will move this here. And for the isAvailable function variable, yes, of course, we will say if if we are on iOS 26 and above, then the local summarizer is available. Otherwise, we will return false, right? So this thing is only available if you are on iOS 26. And then let's do the same for the remote summarizer. And that is always going to be true, because that's just going to be always available. So now we'll have to change that. So let's just quickly check if this still works. So here we are. Select all. Bam, and it still works. Nice. Also, just to double check. I mean, it absolutely must work because we haven't really changed the call structure here, right? So that is still the same. So and here we're using remote inference. So it still works. Now let's make it a little bit smarter, right? So I want to say, well, we've got those two inferences, and then depending on if they're available, I want to call one or the other, right? We can probably let's set up a property for that. Private let inferences. So, oh yeah. So now we can remove the availability attribute here. But now we have to put it in here, right? So if available, hello. Maybe I should just have copied that. No. So here we go. So if we are on iOS 26, then we can actually perform this. Otherwise, this is a fatal error. Good. So now we have our local inferencer and the remote inferencer, remote summarizer, sorry. And then we can go over the list of inferences. Ooh, what is this? We'll do it differently. So we'll get the first one that's available, not random element, but dot first where $0 dot is available. Okay. Yeah, and now oh yeah, we can do it like this. All right, so we'll try to get an inferencer by trying to get the first one that is available, and then we will just call it dot infer input, and we will return the result. Or we'll, yeah, we can return the result. Return try await. Okay, and then what? So this we no longer need. And then okay, so let's take a look at this one here. So sending main actor isolated inferencer to non-isolated instant method infer risks causing data races between. So I think, yeah, this is main actor. So all of these also need to be main actor. Okay. So let's see if this works. Since we're now running on iOS 18, this should call the remote inferencer, and we should probably add some logging here. So in our summarize function, we will first get the first available inferencer, and then we'll call it. So the logging now needs to happen inside of those inferences. So we're gonna take this and go into a logger is not available here. Attempting local, and then let's use this in the remote summarizer. Cool. Let's give it one more run. Yep, so it used remote inference. Let's run it on an iOS 26 simulator. Uses local inference, and that works. So let's now go into this other blog posts and let's see if what happens when I run this. So it runs local inference and there is no output, and that is because this blog post is too long for the token window. So there are two problems here. One is we didn't catch the error. And two is if we catch an error, we then need to go to a fallback inferencer. So let's do it this way. First of all, let's catch an error and log the error so we can see what is happening. And I'll just run this again so we can see the error that we get. Attempting local inference, and why okay, here we go. It was a bit hard to see the error actually. So attempting local inference, and then it says local inference failed. That is our first log statement here using remote inference. So the message is not good anymore. And then exceeded model context window size. I wonder if we get more data by how much it was exceeded. Let's try that again. Yeah, we do. Look at that. Content contains 5,302 tokens, which exceeds the maximum allowed context size of 4,096. So let's That's any error. So let's see if I can catch this error. Okay, so hello. That is interesting. Ah, that's why. Is that possible? No. Oh, wow. No. Well, okay. Okay, so I think this should work. Let's see. Also, it already implemented what I was going to do. Well, let's use this one. Summarize, attempting local inference. We get our error here. Yep, here we go. So but I think that we would have been able to get before as well. Let's see. Let's do this one more time. Can we? Oh, here we are. And the LM error. Yeah, it's not available. Yeah, I think so. We're not getting that much more information. So I'll just switch back to that. And let's do this one more time. Yep. So we're now able to get this error here, and we get the description of the error. And what also happened was when I asked the AI about catching the generation error, it saw what I was trying to do, and then it said, well, we chose the first inferencer here, and there was a problem with the first inferencer. So let's just use the next one. And that is what's happening here. So we get the first inferencer, we try it out. If there is a problem with the first inferencer, we'll take a look at whether this was the remote inferencer, and if it was not, then we'll... Oh wait, why is this? So if it was not the remote inferencer, we will get the first inferencer that is a remote inferencer, and then we will call it, and then if that fails, we will log an error and say, well, that's it. We won't be able to deliver a result. And we could probably say, well, failed to summarize text. Nope. I wonder if we can use defer in that case. It's probably a little bit distracting. Yeah. So let's say, I am sorry, but I wasn't able to summarize that text. Nice. Let's try this one more time. We are on iOS 26. We want to summarize a pretty lengthy blog post. We're attempting local inference, but the text is too long, so we're using remote inference, and that used Firebase AI logic using Vertex AI, and we use the flashlight model. So the request should show up here. Let's reload. No filter, please. Interesting. Why is it not showing up? Oh, it did show up. I was just confused by the time. So it's 21:39, and this is the blog post that we asked it to summarize. We have our text. And here you can see that we're now sending the system instructions in this separate part of the prompt. So in the beginning, and we can go back to a couple of minutes ago. So I have no idea why this is so slow today. So if we go a couple of minutes earlier, let's show 25. And I think maybe something that we did half an hour ago. So this one, for example. So we started at 8:15, right? So this one. Yeah, here we go. So we can even see it here. So it says create a short, snappy, and informative summary of the following text. So let's take a quick look at that. We have the content, and here is our system prompt, or our instructions, which should have been a system prompt. It goes here. So let me duplicate this whole thing so we can see it side by side. And then go back into the dashboard and pick the request we sent most recently. And I'm going to send this to the left. And now you can see that in this request that we sent just 4 minutes ago, we have the text, which is just the text of the blog post we want to summarize. And if we scroll down, here is our system instructions, and it even says this is the system message, role system, and it's, that's also another, it's just a small thing, but using system instructions makes it easier to read those kinds of logs, right? Just another reason why you might want to use system instructions over putting your instructions into the prompt. Nice. Yeah, I think that was mostly what I wanted to show today. So just to go over what we've achieved today, we have created an Inferencer protocol that allows us to say whether or not an Inferencer is available, so that we can say, well, we can have a local Inferencer that uses Apple's language model session to perform local on-device inference using a prompt that we can fine-tune for that. And we can say that this is only available on iOS 26 because it's not available on any previous iOS versions. And then for doing remote inference, we can define another summarizer which uses Firebase AI logic. And thanks to our strategy selection process down here, we can say, let's use a local inferencer first, because that will allow us to do everything on device, no need for any connectivity. And if that doesn't work, because maybe the model is not available, or maybe because the context window is exceeded, we will defer to remote inference. And you can even do this for other models, right? So if we wanted to say, well, instead of using Gemini via Firebase AI logic, we want to use OpenAI's APIs, or we want to use Anthropic's APIs, or something entirely different, that's totally possible as well. We just have to write another summarizer, another Inferencer, do its thing, and then register it up here. And then we would probably also refine the selection criteria, right? And you could do stuff like, for example, use remote config. So that is something that we might look into next time. So if you Firebase remote config, remote config allows you to, well, is there a good, well, we've got this video here, but explore use cases. Let's see. Yeah, so you can define conditions, right? So you could say, well, we want to experiment with different models. We want to see what kinds of models yield the best results and when people are most happy with the results. So you could define criteria and conditions, and you could say, well, there is a new model and we want to test it out. Let's say in a couple of weeks there is the next version of the Gemini model and you want to try it out, but you're not entirely sure if your users will like it. So you'll just roll it out to a certain percentage of the user base. And once you are confident that this works well, you can then say, well, I'm going to roll this out to more users. And what you could do is define those criteria in your remote config backend, and then use this in your client to say, I want to use this Inferencer based on this remote config criterion. And this is, the simplest version of how this works, but we also support Swift property wrappers to make it a little bit easier. So maybe that's something that we can look into next time. So for this time, let's see what people have to say. Yeah, this was awesome. Thanks, Franklin. We'll use this to save money when on iOS 26. Yep. Although I'll have to say, models are getting cheaper and cheaper and cheaper, but definitely, if possible, and you can get the same kinds of results by doing local inference, why not? And now you know one way to do it. So with that, thanks for tuning in, and for everybody who's watching the recording of the stream, there will be a couple of other videos that I would recommend watching, other videos from the series, and maybe even other videos that are slightly related to what we discussed today, and they will appear up there. So have a look, give them a try, and if you like this, do give me a thumbs up. Don't forget to subscribe to the channel and click on the bell and do all the good stuff. Thanks everybody for tuning in. I really like doing this, and it's great to have the conversations with you. And as long as people come and show up, I'll keep on doing this. All right. Thanks everybody. Have a great rest of your day and see you soon.